Julie, are you there? We cannot hear you if you're talking.
Oh, yes. Do you see my screen?
Yes, yes. Looks fine.
Okay. So let me explain current status of the work item of Q19. Yes. In addition to these two work items, J.NoRef and P.Object recognitions, we have two work items. The third one is the J.Source video qualities, objective assessment method for source video quality at the head end. So the summary of this work item is the source video quality at the head end is an important factor in providing high quality programs of a cable network. If the poor source quality will result in low perceptual quality of the end user, even though the programs are encoded at the high bit rate and there is no transmission errors. So determining the optimal bit rate and transmission resolution is very important for the optimal use of network resource. So this work item deals with such topics. So it can be used to determine the optimal transmission resolution and the bit rate in the bitstream services. And we're hoping that upon successful completion of J.NoRef, work item J.Source VQ also can be progressed, possibly based on the deep learning method to develop a new recommendation. And the last work item is J.QUHD, quality measurement method for UHD services. As the UHD services are rapidly being implemented, there is increasing need for UHD service quality measurement tools. In particular, there is a need to evaluate UHD video quality produced by cameras, encoders, editing tools, and decoders. For example, there is some urgent need for subjective and objective tools to evaluate whether or not UHD recording has improved the quality of an upsampled HD or full HD version of the signals. This may not be obvious to people new to the field because they have not accessed the true UHD contents or monitors. UHD differs from the current Full HD on several aspects that can all contribute to affect the perceived quality. Very high resolution, large size of UHD displays, shorter relative viewing distance, and wide viewing angles. Furthermore, there can be a distortion due to camera capture and the movement, and improved subjective method are also of interest. So this work item aims to develop new recommendation for subjective and objective perceptual video quality measurement method for UHDs. So this work item recommendation can be used to determine the UHD and Full HD resolution and bitrate in bitstream services. So also for this one, upon the successful completion of J.NoRef, this work item also can be progressed to develop recommendations. Let me show you some of these current status of these work items. This is the current document, J.New UHDs. As you can see here, the difference between the UHD and the Full HD is very, very small. So then the question arises whether we want to go to UHD resolution just for this small improvement in perceptual qualities. That is kind of a big issue for the program service provider, because going from Full HD to UHD, the bandwidth increased significantly. On the other hand, the perceptual quality improvement sometimes can be very minor. So for optimal use of network resource, we need to determine that whether this UHD contents is worthy to be transmitted in the true UHD resolutions, or in other words, 4K resolution instead of 2K resolutions or 720p resolutions. So this is a big issue for the optimal use of a network resource.
So sorry, actually, this comparison was that made based on the optimal viewing distance for
yes, in accordance with the UHD. This one follows the IT recommendation 1.5H, 75-inch TV.
Mm-hmm. Okay, interesting.
This one is the average of 40 source, so not just a single one.
Right, and the source were a kind of a mixture of content.
Yes.
Mm-hmm. Okay.
So this source is high quality because we got from the broadcasting company.
Mm-hmm. Okay.
So this one is some kind of individual analysis. For some cases, the Full HD is slightly better, but usually the UHD is something like shows a slight improvement. But on average, the difference was not that big.
Okay, just one more. The video was shown uncompressed, or were there some kind of encoding also involved here?
No, in this case, there is no co-encoding, just downsizing. Downsizing from this one to this one, nothing else.
Okay, thank you.
So this is the same one. And also we compared with the 60 frames per second and the 30 frames per second. On average, 60 frames per second is slightly better, not much. As you can see here, the UHD is, on average, is slightly better than the Full HD, but the improvement is very, very minor. So for example, if the UHD signal transmission result in something like a 30% bandwidth increase for something like a 5% perceptual quality, then the question arises that whether this is worthy to send the UHD signal or not.
I think this could be used also for the argument of energy savings if you have very little degradation going for the lower resolution and lower frame rate, then will be saving energy to send.
Yes, that's very true.
What I have is the absolute number or the when it comes from 1 to 5.
Yeah. Yeah, I think that's my opinion. I mean, yeah.
And also, this one compares the perceptual quality in terms of the encoding the bit rate. So for HD, we encoded something like a 7 megabps, and sometimes some of them is over 10 megabps, and UHD from 10 megabps to up to 40 megabps. But as you can see here, even though you encode that 40 megabps, the improvement is not that significant. So it may not worthy to send the UHD signal at 40 megabps because we increased the bandwidth by 4 times, but this distribution is not that large. We have a slight some density here, but in general, the question arises whether this is worthy or not, because we are using 3 or 4 times more bandwidth. So this one compares the 40 sequence individual scores. So on average, the UHD is slightly better, except for some of these data sequence. But the difference in many cases is very something like 5 to 10%. It's definitely UHD is definitely better than the 720p, but between the 720p and 1080p is kind of significant. But these two is very similar. So we tried predict this UHD Morse score using deep learning method, and we used ResNet 101 as a backbone. So we used the 3 data set. One is used, and then it apply to other 3. So we have some, even though this is kind of NL method, we obtained some decent performance. But on the other hand, all these data set, because they are similar in nature, I think this kind of method should be tested using some significantly different source characteristics. So, but we did this experiment and obtained that it may be possible to predict the UHD quality based on deep learning method. And this one,
sorry, did you compare this also to some full reference method?
No, you cannot use full reference because there is no reference here. Okay. This is old source, no reference.
Right, okay. Okay, thank you.
And also we tried to use another architecture, a deep learning architecture, to predict the UHD Morse scores. And this is the result. Looks like the correlation could be 0.7 or 0.8. So this one is promising, but as I told you, that all this training and validation data set is similar in nature because they came from our libraries. So when this one is applied to different library of a source, then we may have a lower performance. But on the other hand, to obtaining this kind of a high quality UHD source turned out to be very difficult. So the research we can do on this topic is at the moment kind of limited. But if there is some enough interest in these areas, I think we can continue to work on this one to develop recommendations after, if we successfully complete the NL method. Okay, so this is the current document. So this document, if we have account, IT account, I can give you the current TD numbers. You can download it now from the ITU, but I'm not sure I can distribute it to the VQuick or not. I need to check the ITU, but if we have ITU account, you can download this document.
Did you also publish the study?
Some of them.
So one way would be to also kind of put the reference to the studies. Maybe they are already in the document, but maybe you can put it in the notes. Then, if one don't find the paper or this report, one can go to the paper.
Yes, I'll put the TD number here. So if you have an account, then you can download it. And also I checked with the with IT or TSB. Although it is not possible to upload this document to the VQuex site, they may allow me to send this document as a personal mail. So I'll check with them. If they say it's okay, then you can send me email, then I can send you this file.
Okay, yeah, thank you.
So, and this is the current document of J.NOREF. This has been quite long, and there are also some collective data. After many try and failures, this one kind of put in sleep for some years, and then the deep learning method came out, and they published that they achieved the magnificent performance. So we also tried NL method, and it turned out that they are indeed show some good performance. So this new research result prompted that renewed interest in these work items. So this is another one. And then we did some experiment. We used this one's a CVD 2014 is in the public domain, and the CONVID and the live Qualcomm's and UHD data set. This one we generated by this data set is generated by Yonsei universities. And group 2, this one has 2 sets, but this one we didn't apply any codings. This one is just resolution change. And this one is the UHD data group 2. And in this case, resolution change and coding included. And this one is the number of PBS for each set. And also we have 2 full HD data set. And this data set we generated during the FINAT phase 3 project. So we generate something like, I think, about 20 data set for the project. And most of them is UHD resolutions. And this one shows the result. This diagonal means that we used this data set as a training data and then apply to other data set. For example, when the network is trained using CONVID data set, so within this one, they showed kind of similar performance. But if they go to the other areas, for example, they go into the full resolution of UHD resolutions, then suddenly the performance drops significantly. Full HD, furthermore, in this case, just the correlation is 0.1. But also when this network trained on CONVID apply to UHD with encoding, this one is no encoding, NC means no encodings. Now we have negative correlations. So you can see the similar performance for the CVD 2040s. In itself is 88, but CONVID 0.5 and 0.37. From this, it looks like CONVID is a better training data set because when you train your model using CVD 2014, you have a poor performance to other data sets. At least the CONVID is more consistent. But even for this CONVID, when it applied to Full HD and UHD, they show very poor performance, negative correlation. Live, when trained on live data set, in itself is 7.76, CONVID 6.4, and for the CVD 1214 is 0.46, is small. But also this has very low performance. But on the other hand, this one is a UHD, resolution change and encodings. So they have similar impairment characteristics. As you can see here, the diagonal term, the training accuracy is very high, and when you apply to other data set, it's pretty decent. It's not so bad. I think almost everything is over 0.7 or 0.8. But when this one is applied to this one, lower resolution database, we observe significantly lower performance. So in this NL method, based on the deep learning method, training data is very, very important. Well, I think it's rather fortunate that in this NL project, we are going to deal with just the full resolution. So we now have a focus. So I think if it comes out successful, then I think we can extend the scope to the other resolutions. So as you can see here, when the training and the test data has a similar characteristic, they show good performance. But if they show significantly different, we observe poor performance.
It's a very interesting result. Just maybe you can remind the models that you were training here. What models were it? Was it your own or some?
Well, this is kind of our models. We modify the existing models.
Okay, yeah. So it's the result of one particular model that you produce that gives this this result.
Yes.
Okay, yeah.
So I think that the NL method based on the deep learnings has some promising potentials. On the other hand, there is some danger that they can be biased toward the training data set.
Yeah, very nice.
But on the other hand, now the dark side of deep learning method. All deep learning method has these adversarial attack problems. For example, this one is recognized as a bakeries. But when we change slightly, this one looks exactly the same, but now this one is recognized as books. So this one, it is very easy to fool CNN-based architecture to make them wrong decisions. And we found out that in a similar way, we can also fool CNN-based NL method to make this kind of mistake. For example, they are all identical, but we made a very small change. Now the deep learning-based method say this one has Mohs score 3.4. This one, Mohs score is 5. This one, Mohs score is 1. So it is possible to fool CNN-based NL method to make incorrect decisions. So all CNN-based method has these reliability problems. Still, this one is still open questions. So in this NL and the JADA no reference project, if a lab produced some model based on the CNN, they always have this kind of a risk that their model may behave unexpectedly for some data set. This is another example. We added noise, but we made a slight change. Now they have exactly the same Mohs score. So we can do it very easily for any CNN-based NL method. So also when we tried to training the CNN-based NL method using larger data set, and this is the result we obtained. We tried several architecture. So they show some result, but some of them shows a good result. for some data set, their performance is not so good. So I think that the question is, how can you balance the training data set so they can show us show the consistent performance? I think this one I showed during the last Bitcoin meeting during the Q19 interims. So when the data is applied to new data set, their variation can be very large. Also, this document, I can add this TD number there. So if we have the ITU account, you can download it, or after I check with ITUs, I may be able to send it as a personal email.
Did you also publish this result?
I guess some of it.
Mm-hmm.
Okay, so also let me show you some of the current. During the previous VQuag or ITU project, we generated, I think about around for the full HD resolution and UHD resolution, we generate, I think, 30 or 40 data set. So we used one of those data set, and then we download some NL-based video quality method. It's because many of these algorithms is publicly available. So we apply to our data set. So this data set is never known to the developer of this 5 method. So this one is full HD resolutions. I think this one is in accordance with one of the ITU project. So the data set is valid and well balanced. So as you can see here, the UVQ 0.6, BRISC 0.5, NIQE is 0.6, PIQE and 0.6, B-blind 0.1. This is very poor performance. So
this is correlation, right?
Yes.
Mm-hmm.
So I think if we can reuse the subjective data, the subjective and objective data of this data no reference model, I think we can do some extensive performance evaluation of existing method, because the data will be well balanced and the data size is sufficiently large. So for this kind of comparison performance can be very useful for the communities. But as you see here, sometimes their performances difference can be very large. But I just want to make, so I warn you that this is just a single experiment, so their performance may be significantly different for other data set. So this one is just a simple illustration, may not represent their true performance. So this one is the scatter plot of a BRISC, UVQs, NIQE, so it says a strange outlier, PIQEs. So as you see here, PIQE, for example, it has a 60 score, but the most score can be 0.2 to 4. That's a huge range of variations. So I think even though the NL-based, the deep learning-based NL method is promising, I think there are some rooms for the improvement. So I think if we can produce some NL model with reliable NL model, I think that can be a big improvement and contribution to the field. And based on the result, we can continue to extend the scope of NL models, maybe can go into UHD or other resolutions. So I really hope that we can produce some good output out of this JDAN no reference project so that we can continue to improve the method for other applications. I think that's all I have at the moment. Any questions?
No, I mean, I agree. It seems very promising, and you showed a lot of interesting results. I can, when it comes to this project, no ref, I think if we can try hard to make the output with the subjective data PVS is open, that would actually be a major contribution here. I mean, not only the result on what models are the best, but also data that could be substantially used further on. But yeah, I know all the problems around this, but I think if we make the upfront effort that this would be part of the scope, I think we have a bigger chance to succeed, and it would give much more value in the long run to the community and even to ITU. I mean, even if it leads to a recommendation now, I think that having the open data set would be actually the core value of the project if we succeed to do that.
Yes, I agree with you. So let's do our best. At least each lab that performs subjective test can retain the right to reuse it and possibly extend it to ILG or other proponent so that we can start construct some new databases, and hopefully some of the labs are generous enough to release their subjective data set so that this data can be used by other people in these areas.
Yes, very good.
Okay, so I think this is what I have at the moment. I'll send you share this document with the TD number, so you can upload it to the VQuack site, so they can.
Yes, CC Margaret also, of course. It may be some delay in uploading because of Margaret being away, but yeah, please send me them, and I will just in the meeting notes of WeQuag, I will just refer to these presentations. So because you kept the notes there, and it doesn't make sense to let's say copy and paste the information into the meeting notes. So
yeah,
if
that's correct.
But you, then we will try to do it that way.
Yes, I think this PPT can convey much better the decision and information needed to understand this project.
Yeah, exactly. Yeah, very good.
Okay, I think this is what I have. So now I think, Cheryl, you can take the chair and wrap up the meeting if necessary.
Yeah, thank you so much, Julie, for all your input and work for the meeting. So, is there Anything else anyone want to bring up before we close the meeting? Okay.
Sorry. Before closing, as we discussed yesterday, so we need to send the device working document to JP and Martin Aldo. So I think he will send soon as soon as possible. Yeah.
Yes, I'll take care of it. I think everything is fixed. I think almost every proposals by entity is agreed. Only the exception is that instead of uploading your file into FTP site, you just send it to Martin as an emails.
Yeah, of course.
Other than that, I think all your proposal is approved, including the deadline. So I think you can just update the uploading part. Then I'll take care of from there. I write a report 219 interim meetings, and also I attach the 3 revised document as attachment.
Yeah, thank you very much.
Okay, is that you happy? Okay, good. Adi, do you have anything you would like to add for before we close? I think we need to approve the minutes from yesterday to today, but it's just very short. So let's do that, and then we can close it. Okay, I will share my screen. Yeah, so for the last, for yesterday and today, I just put in very brief information. Maybe the most important is referring to these which will be contained in the action notes and information about what's took place. Maybe I should put the action point on me too when I get the slides from Julie to enter the name of the presentation into these notes. I will put an action point. Can we approve the minutes, or do you want to add something or change something to this? Sorry, brief. Okay, hearing none, I assume it's meeting. So finally, I would like to thank the host again, Adi, and you extend my gratitude to Christian for hosting the meeting. It has been really, really amazing. All the arrangement, I mean, all the work you put in here, we really appreciate it.
Thank you.
And give him an applause. Thank you. And with that, we close the meeting for this time. Thank you.
Okay, thank you.
Thank you, Mr. Chair. Yeah, the chair.
Okay, thank you very much.
Thank you, Julie. See you.
Thank you. Thank you for everything.
Mm.